Alright, this lesson is inequalities in two triangles. The objectives for today will be to apply inequalities involving two triangles. Alright, let's see. First theorem is the hinge theorem, and it says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger included angle. So, let's take this a step at a time. So, if two sides of one triangle, so let's draw a triangle. We'll call it ABC. Then we have another triangle. Oops. We'll call that triangle DEF. Okay. And I know two sides are congruent. So let's say AB is congruent to DE. And we'll say that AC is congruent to DF. And the included angles are not congruent. So that would mean, say, something like, I don't know, this angle is, say, 45 degrees, and this angle here is 20 degrees. Right, so that's saying that I know angle A, or the measure of angle A, is greater than the measure of angle D. Then the conclusion is going to be that segment BC well, the distance from B to C is going to be greater than the distance from E to F. Alright, now we're going to look at the converse of that. So we're going to go backwards. If two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the third side. So same idea. I have ABC, and then I have another triangle. Okay, so same hypothesis. I know segment AB is congruent to segment DE, and I know segment AC is congruent to segment DF. This time I'm told that segment BC is bigger, so let's say that that's 10 units, and this one happens to be 4 units long. So again, that means segment BC, or the distance from B to C, is greater than the distance from E to F. Your conclusion would be then that the measure of angle A has to be greater than the measure of angle D. Alright, so now we're going to look at some examples. And it says compare the measure of angle BAC with the measure of angle DAC. Okay, so I notice segment BA is congruent to segment DA, and AC would be congruent to AC. It's going to be congruent to itself. Alright, so since the distance from B to C is 7 units and the distance from C to D is 6 units, that means then that if I compare that angle to this other angle over here, looking at the opposite sides, I would say that the measure of angle BAC AC has to be greater than the measure of angle DAC, since this side that's opposite the angle is larger. That means this angle has to be larger. Right, and if I look at example number 2, it's asking us to compare this side EF with this side FG. Again, notice that EH is congruent to HG and FH is congruent to itself. Alright, so first thing we have to do is we have to find out what this angle is right here. Okay, notice that this forms a linear pair, so this distance right here has to be 180 degrees. So 180 minus 82 is going to give me 98 degrees. So I know this angle right here is 98 degrees. And since it's larger than angle EHG, the one on the left, if I compare this side to this side, FG, the distance from F to G has to be greater than the distance from E to F because the angles. The 98 is greater than the 82. Alright, let's look at this third example. It says find the range of values. Okay, looking at the picture, I know that LP and LM are congruent. LN is congruent to LN because of the reflexive. So that means 5K minus 12. This is the smaller side, so I know that 5K minus 12 has to be less than 38. Alright, we add 12 to both sides. Means 5K has to be less than 50, which means K has to be less than 10. Alright, now we're going to look at some proofs. So the first one is we want to prove that the distance from A to D is greater than the distance from C to B. Alright, so let's make our 2-column proof. Remember that on the left side goes our statements, and on the right is our reasons. Okay, we always start with what's given, so I know that segment AB is congruent to segment CD. And they also told us that the measure of angle ABD is greater than the measure of angle CDB. Okay, so I'm not sure what this angle is. I know that it's bigger than this angle down here. So what I'm going to do is I'm going to put this little arc, and I'm going to put 2 so that I know that that one is the bigger one. And I'm going to put 1 there so I know that that one is the smaller one. Alright, and then I have to say that segment BD is congruent to segment BD because of the reflexive property. Alright, so I got 2 pairs of sides that are congruent, and I know one angle is bigger than the other. So that lets me use the hinge theorem to say that the distance from A to D has to be greater than the distance from C to B because of that hinge theorem. So since these 2 sides are the same, this segment is congruent to itself. If this angle up here is bigger than this angle down here, that means this side AD has to be longer than this side CB. Now let's look now at the next example. So again, we have to make this two common proofs, statements, and reasons. We know C is the midpoint. Of BD. We know the measure of angle 3. Is greater than the measure of angle 4. And the measure of angle 1 is equal to the measure of angle 2. All that is given. Alright, since C is the midpoint of BD, that tells us that BC is congruent to DC, definition of a midpoint. So we'll go ahead and label our picture. And since the measure of angle 1 is equal to the measure of angle 2, that tells us that angle 1 is actually congruent to angle 2. Oops. Definition of congruent angles. Right, 1's congruent to 2, which then means that segment AC is congruent to segment EC. Right, and that's going to be the converse of the isosceles theorem. The triangle theorem. So since these two, angle 1 and 2, are the same, that means that this side here has to be congruent to this side here. Alright, so then looks like I have my two pairs and I know the angles. So then that's it, AB. Because in our givens we said that 3 was bigger than 4. So that means that AB, the distance from A to B, has to be bigger than the distance from E to D. Which again, that's the hinge theorem. Right? Because the hinge theorem, then that means that if this angle is bigger than this one, then that means this distance, this side right here, has to be bigger than this side over here. And we're done with our proof.